Hi there, welcome back to the Engine Performance Expo. Lake Speed Jr. again with my good buddy Cass Choate here at Choate Engineering, aka the Diesel Doctor. Tell me what's your proper name, my friend.
Hey you. That's pretty.
Hey you.
Hey you. Though I'll answer to anything. Pretty much.
I grew up the same way, by the way.
Did you?
Yeah.
Yeah. So we, well, this is a big year for us. So we just changed. We're known as Diesel Doctor, but we've since moved into a much larger facility. And
it's really big here.
Yes, it's at the old place. We had to go outside to change our mind, but but it definitely has been a welcomed expansion. So
you got some elbow room here. Is it? You said 4 acres under the roof?
4 acres under the roof, 5 acres outside. So yeah. Now we can really stretch out and expand the business, and that was always a big hindrance for us. So but with that. We always had the repair facility was based off of the Diesel Doctor. Okay. So that's how I actually started. And so when that changed, we started progressing more in the engine building and part manufacturing. Okay. And from that, I wanted something that I could put my name on. Sure. Literally. Yeah. Own it.
Like a valve cover?
Absolutely. And so there's nothing more personal than that. So something you take, you work hard and you take pride in your work. And that's cool. More personal than that. So.
Well, that's how I've always known you, was from the part manufacturing side. Yeah. So that was like, okay, it was Diesel Doctor, Joe, I don't know. Anyway, so now we got a little backstory here. Yeah. So you just moved this past year to this new facility. Yeah. So a little bit of rebranding, expansion, a little more focus on this. I mean, not taking focus away from the repair side, but just adding on.
Yeah, just adding on. Starting out, in order to progress in a business and really know, and I think we've talked about this before, but starting and tear down is often the best way to learn.
Yeah, you were reading my mind, right?
Yeah, so
you saw all the problems firsthand.
When you're a mechanic, you definitely see that. You're like, oh my gosh, this guy's coming in, he's got an old leak. I already know where it's coming from before I get those phone calls all the time. I've had people call me and literally I'll walk in and I'll hear the customer service and I'll hear one of the guys on the phone and he's already telling me about an issue and I can overhear the conversation without
you already know,
and I'm just over there, put it on hold. Okay, this is his problem. He doesn't have this torque converter seated. That's the reason why.
Exactly.
It's just something simple like that. But as a mechanic, you're constantly seeing problems, and you see them specific year model problems, not just straight across the board. So you're seeing the differences maybe from a 94.5 7.3 all the way to a 2020 or 2000 whatever. Engine or whatever it might be.
Whatever iteration of the design spec was at that time.
Pick your poison.
Right, got it.
So that's basically how that works. But being that we were able to see the mechanical failures from the mechanic standpoint and also from the teardown guy, I got really acquainted with not just the nuances and the idiosyncrasies of the engine and the assembly and which part fits what and how this works and what the geometry of it is, but what we saw continually failing. And that's what necessity is the author of invention, and that's that's the biggest help for me, was being able to see what failed on the guy's truck, and then that leads to the question of why did it fail, and then thirdly is what can we do to keep it from failing. Yeah, exactly.
And that's where the Haas CNC machines come from, right? How do we fix this? We're going to make our own parts.
That's exactly right. So that's what we've done, and it's worked really well, because starting as a mechanic, I was trying to get good machine work, and then from there, it just kind of exploded into what it is now.
Obviously, the Powerstroke is one of the engines you work on. It's not the only thing you do.
Ford, Chevrolet, Dodge, Cummins, Duramax, Powerstroke. That's our mainstay, and we are definitely branching out into some of the smaller. As we're seeing more and more, I was telling somebody the other day, I think it was Keith, we were talking, and I said, during the pandemic of 2020, we saw that there was a growth of 28% in the diesel market, which everybody was fire sale. I mean, I bought some equipment pretty cheap during that time because, everybody's ready we don't know what's going to happen.
Oh, exactly.
But with that being said, one of the biggest things that you see is that the ever-growing market for campers,
Oh yes. Oh yeah.
Big. That was one of the biggest things that that really grew during that 2020 chaos.
Makes sense.
People were ready to go somewhere. And so the campers don't get smaller. It's like Big Macs or...
No, everything gets supersized.
Yeah,
right, exactly.
Look at people. I mean, everybody gets bigger, the camper gets bigger. What's it going to take? It's going to take a diesel truck.
Yep.
So that's definitely helped us. That's helped our market. So yeah, it's been good.
So specific to the Powerstroke platform, talk a little bit about the things that you've learned and maybe some of the parts and things you've developed that are help solve some of those problems along the way.
Sure. Well, if you want to go to the holy grail of all diesel engines, and I'm not talking about the 12 valve, we're talking about Powerstrokes.
Okay.
Guys get really, they are hardcore avid diesel lovers. I mean, when you talk about the 7.3,
I knew that was coming, right?
You're talking about, those,
passionate.
Yeah, best diesel. Those are fighting words. If it's not the 7.3,
I mean, they're kind of like Mopar guys, right? Sorry, Mopar guys, I had to throw that out there, right?
Exactly.
They got it hard. They got it bad.
Somebody's got to do it, right? but anyway, so the 7.3 was definitely a solid platform. But the thing that we've seen a tremendous change in is the way that the end user looks for the diesel. I mean, back in the day, we've talked about how the Oldsmobile, diesel engines were absolutely the worst thing you could possibly think about as far as drivability. And for the end user, it's smoky, it's laggy, it doesn't start cold days, and when it does start, you better let it sit there and warm up. And it was not a pleasurable experience owning a diesel engine back in those days. However, that's completely changed nowadays, and people are thinking, the engineers specifically, are thinking of how can we take a diesel engine, have the torque of the diesel engine, have the longevity of the diesel engine, yet have the drivability of a gasoline. Yeah. So the 7.3, and I say all that to say that the 7.3 was the predecessor. It was the dinosaur that they said, hey, that's a T444E, the first Powerstroke. They just yanked it out of a dump truck or a school bus and said, you know what? What if we just stuck that in that truck over there, And that's basically the way it worked. Same thing with the 6PD Cummins. I mean, Komatsu used them in dozers for years. So it was an industrial application.
Yeah.
It's an industrial engine. You stick it between the frame rail and, you put it behind an automatic transmission, say, hey, we've got it. Here you go. And so it still would serve all the purposes that it was intended to do, but it still drove like a dump truck.
Right.
It did not have the drivability. And of course, with aftermarket parts, we can always, fix those insufficiencies or inadequacies in the engine. But the 7.3 had a few problems, but very minor. There really wasn't a whole lot there. So
was that with their first generation with the we'll call it newer multi-injection strategy?
So that actually came out, and the multi-injection actually took place with an AE and AD code injector. That's when they changed. So they didn't actually split that until. The funny thing about it is 98. There was no such thing as a production year for Ford for a Super Duty. So late 99 is when they went to split injection. Okay. So they didn't start doing that. So when we saw split injection, we saw a tremendous amount of differences in the tone. It quieted the truck.
Right, exactly. So that's interesting because as an outsider, kind of looking into the diesel market from a little bit, it's always kind of struck me that, the reemergence, if you will, of diesel power. That had to be just multi-phase injection. That was it, right? It's like diesel's a diesel. What did you do to make it powerful? It was the injection that kind of turned everything loose and made it where, man, we could really start doing some interesting things here. And then I guess engine management must be part of this too.
Definitely was. The big thing where you started changing was, keep in mind that for many years, they had the 6.9 and then they came out with the 7.3. And a lot of folks don't realize there's a 7.3 indirect injection. And there's a 7.3 direct injection. Okay. Well, the 7.3 direct injection was 94.5. That's when it was commonly termed as a Powerstroke. Okay. So indirect injection was, it's kind of like the guy that threw the grenade and just waits for something to happen. That's indirect injection. It's a small combustion chamber. It explodes and then it spreads this explosion into the to the cylinder itself.
My 83 Mercedes.
Exactly. Right, yeah. Nothing happens really fast, you know.
No, nothing happens fast.
Anticipate the truck coming before it comes, right? Yeah. So you know that there's a 5-second lag. Yeah. That's just the rule, right? So that really made a big difference. So even before the ECUs were developed in order for that to take place, direct injection.
So direct injection was probably the first major step in kind of elevating the performance capabilities of a diesel. Then you get into ECU. Then you get into multi-phase injection. They go hand in hand, right? You can't have one without the other.
Yeah, and there's a lot that changed there. So 93, 94-ish, there's when they first introduced the turbocharger. Okay. And so that was huge, okay, when that first came out. And then intercooling. That was big, because if we can lower the mass air densities, the mass air density, we can definitely create cleaner combustion and more complete, more power. And then from there, that's when we started. That was when the direct injection came out and the Powerstroke engine came out in 94.5. That's where we went into the Huey injection system. And if you get bored with this and fall asleep, I don't blame you. But it's called a hydraulically actuated, electronically controlled unit injector.
Yep.
Okay, so basically all it is basically an intensifier piston that magnifies whatever the pressure is on the top side 7 times to whatever comes below it.
Right.
So if you have 1 pound of pressure on the top, you got 7 pounds of pressure coming out. So what it is?
It's a really complicated way of mechanical fuel injection.
It's a very complicated way, and it was from Caterpillar that actually came from.
Right.
But they were the ones that were internationally used. But Caterpillar was one that designed that first product. But it's basically like if you think of it like a syringe, and that's just the way that it works. Except the guy, instead of you pushing down with your thumb, we're going to do it with oil pressure,
right?
And then we're going to make this piston make it be able to magnify it times 7 due to the geometry. So,
I might know a guy that has a little bit of experience with tribology that knows a little bit about what that does to oil.
I think I know the same guy you're talking about.
Yeah. I think we know the same guy. Anyway, carry on.
So the Huey injection system was a great. It really did work well. You really can't complain about it. The big issues that we see with those were common issues were the say O-rings on injectors fail. But as the way that turns out, most times people don't realize the effect. They realize the cause. They don't. A lot of times it was oil temperatures that they were seeing, and that would cause excessive wear on O-rings and the seals that were being used. So you'd start seeing where these seals are under maybe 3,800 pounds of pressure, they would allow oil to get into the fuel, and it would just literally eat itself. The great thing about the 7.3 is you couldn't kill it simply because if it got low on oil, that was its lifeblood to fire the injector anyway. So it just shut off.
Right.
So many times I've had people call me and say, "Man, I can't get my truck to start." It's like, have you checked the oil? No, but that's not going to do anything. Just check the oil.
Just try me.
Right. Yeah. So that's, and they kept that design from the 7.3 and they carried it over to the 6.0. And the 6.0 was definitely more problematic with that design and the simple reason for that is, there's many reasons, trying to keep it as short as I can, but oil temperatures, they changed their oil cooler to be much more compact. So you had 7 layers of cooling. 7 for coolant, 7 layers of oil. Because of that, it's a much more compact design, and it did not provide as much heat dissipation as needed. And the engineers just missed it. And not only that, they had a lot of issues with a lot of the sand casting in the blocks. So what would happen is that sand casting, instead of getting it out like they should have, we've got a really small coolant passage now, and it'll get plugged. So, and then on the backside, it's like a perfect storm. Right. If you were just going to create disaster and you were going to sit down on a piece of paper and plot it out, like how can we just absolutely have the worst case scenario come out and end up with blown head gaskets? This is the way we're going to take the paper trail. That's what they did. So what they did was they had an oil cooler that's too small, a block that's nasty, and then they hooked an EGR cooler in behind that.
Oh, that's great, yeah.
And you know what happens there. So we have the oil cooler now that gets plugged, and because the oil cooler's plugged, that's the coolant that feeds the tubes for the heat exchangers inside the EGR cooler. So when that happens and they crack, well, guess where the coolant goes? Down the intake. Yep. Oh, but one more thing. Let's put 4 cylinder bolts on the head instead of 6. So, what do you think will happen with that? We're going to lift the head because it's not compressible.
Of course.
Blow the head gaskets, and then, the rest is...
Plus, glycol and oil is a great mix.
It really is.
It really is a wonderful thing to see glycol and oil mixing. Really a whole lot of fun.
It's pretty amazing to see how corrosive that is on cylinder walls, too. It amazes me. The sad thing is you'll get a guy that like, man, I parked my truck. It's got 60,000 miles on it. And I was trying, true story, a guy telling me about it. It's a Harley Davidson edition. I remember because I wanted one so bad I couldn't stand it. It was captain chairs in the back. Really, really nice truck. Yeah. Oh, it's clean. And the guy's like, I was trying to get this thing out of I had a trailer and I got stuck. And this thing started puffing out white smoke. So I just parked it in my yard for 4 weeks. 5 weeks, whatever it was. I think for a couple months. Then he brings it up to me. Well, we knew that the EGR cooler had ruptured. Well, we went ahead, go ahead and bulletproof it as it, pull the head off, and the cylinder is completely pitted all the way around. You can see where the piston stopped, and the coolant has just decapitated it.
Yeah.
And you have to tell a guy, 60,000 miles, this truck that is a beautiful truck, doesn't have a scratch on it. You need another engine because...
Right, yeah, the whole engine's gone. Just take the whole thing, throw the whole thing away.
If you'd have just brought it to me the day it happened, it wouldn't have cost you an engine. I could have fixed it.
Right.
But you let it sit.
Yeah.
And they thought they were doing right by that.
Of course. And life happens, and next thing you know, and corrosion does its thing. So
exactly. Well, I'm sure that he probably got some advice, via...
from the internet, right?
There you go.
Yep.
There you're going to start that one.
Oh, well, hey, listen, that's the whole point of the Engine Performance Expo is that we want people who are watching to hear from people like yourself that have been there and done that. Like, you can see this man. You can see the parts he works on, what he's done. You're not hiding behind a keyboard.
No.
Because unfortunately, and I've seen it in my own professional experience, there are people that are keyboard warriors that don't know what they're talking about.
No.
They don't. I mean, it's shocking to hear that there's something on the internet that would be misleading.
Yeah.
It happens. So the idea is that let's have a resource here. Right. And that's the idea we want to talk to you about, the Powerstroke engine, is to say, hey, what are the pros? What are the cons of this engine platform? Because we do know it's a very popular platform. There's a lot of them out there, and you can do some pretty cool stuff with them. So, share those pros and cons, and what are those really cool things you can do with them?
Sure. Well, it reminds me of Brad Paisley's song, So Much Cooler Online. I don't know if you're But, the people are all mechanics online.
Oh, yeah.
And there is some good information out there. It's just, you need to be a professional to be able to know whether it's good or bad. Mm-hmm. That's the bad part of it.
Right.
But getting back to what we're talking about with the 6-liter, that pretty much spells out the disaster from there.
Okay.
On that 6-liter, that's cut and dry. The biggest thing is again, oil temperatures, because if you're constantly having a problem, they say that the definition of insanity is doing the same thing over again.
Expecting a result.
Yep. So people will replace O-rings on injectors, or they'll replace dummy plugs and standpipes, and expect, why is this thing continually, failing on me? And I see that all the time. And you're like, wait a minute, let's figure out the why. And so definitely the 6-liter had some major drawbacks. They went through, from 2003 to 2007. Mm-hmm. So the way that breaks down is 94.5 is the first year of the Powerstroke, and we carry that all the way out to 2003.
Okay.
That's the last year of the 7.3 rolls off the line.
Okay.
Again, now we're starting to come into emission standards.
Yep.
Everybody's favorite topic. Right? Yeah.
DPF, we love them.
Oh, yeah.
DEF fluid, all those great things.
Sure. We start seeing that in 2008. But between 03 and 07, the EGR cooler that was never seen before, it surfaces, and boy, does it make itself known on the scene. And it costs a lot of people a lot of money because, again, for that very reason that we discussed about the failure. But moving on from the 2007 platform, they kept the vans because they couldn't stuff this in a van. The 6.4 just wouldn't fit. So they kept the 6-liter around till 2009 and 10 for the vans, and or 2009 I believe it was. And anyway, the 6.4 came out because of course emission standards.
Right.
So now we are not only playing with the EGR cooler, we've got 2 of them.
2 of them now.
2 of them, yeah. And also now we have Potato, a very large one in the tailpipe. But the engineers have completely, in a stroke of genius, designed a wafer catalyst system to now, in order, because we need the DPF to burn off the soot that we're going to place in it by filtering the exhaust. Really, what would be the best thing we could do is let's just shoot fuel in the number 7 and number 8 cylinder on the exhaust stroke, and as it comes up, it'll just kind of get in the exhaust.
It'll burn it all off. Oh, exactly. Yeah, that's the way it works.
That works great.
Yeah. The best thing is, we'll come up with a really cool name for it. We'll call it regeneration.
Right. That sounds like it's productive or something.
Yeah, it's regeneration. It's great. It's good stuff. Right?
Yeah, that's
we're not just dumping raw fuel in the exhaust.
Because that would never wash cylinder walls.
Never.
I mean, diesel fuel is a great lubricant for something.
It's better than gasoline.
Yeah, that's the truth. But anyway, so it washes the cylinder walls on number 7, number 8.
Yep.
And people are having low compression issues. One of my favorite things to read is...
Is that where some of the oil consumption started coming from in those? Because it kills the cylinder and then...
Yeah, there's... well, one of my favorite things to read is it's almost kind of like those... you ever read those... things like back in the 1950s, they'll say, smoking's great for your child. It's got this pregnant woman, and she's over there, obviously, and the kid comes out. And,
yeah.
He's a Mopar guy. I'm sorry, no. But anyways, smoking does affect, obviously we know the cause of the problems there. But they did the same thing in the manual. Like the 2008 manual says, it's not uncommon, I think it says, to see 3 quarts of extra, 2 to 3 extra quarts of oil that you'll find when you drain your oil. Between changes. True.
Quarts of oil. You mean 2 or 3 quarts of fuel.
Right, exactly.
Okay.
Yeah. I mean, if you got somebody over there, your neighbor, and he's actually over dumping oil in it, maybe that may be okay.
Right.
But we're going to call it, for warranty's sake, we're going to call it oil. Otherwise, so that's definitely been a big problem for them. That didn't really help bearings.
I bet it did not.
On top of that, the 6-liter, again, we talked about the Huey injection system. And how when a Huey injector fires, it spits oil and sprays it over the top of the rockers. Well, the relationship was, to say the least, very strained between Ford and International. They weren't very happy with one another. Ford was paying out quite a sum of money in warranty claims during that time. And they came to International and just basically told them, look, if you'll just get us till 2011, we're going to be done with y'all. And we'll make our own diesel engine. Which is kind of interesting because they've never done it before in-house like that. So International said, we'll fix you right up.
We got a deal for you.
So anyways, what they did, and man, so basically what they did was they go, Ford said, we've had it up to here with Huey injection. We don't want it anymore. You can't meet emission standards because we need to increase the atomization for the fuel in order for it to incinerate and burn complete.
You need more pressure.
That's right. So instead now of seeing pressures of, again, with that intensifier, maybe 22,000 pounds of pressure, we need to get it up to about 26,000 pounds of pressure.
Common rail. High pressure common rail. Yeah.
Okay, so what we're going to do, and this is the 6.4 is the first cousin of the 6-liter. They pulled the high pressure oil pump out. They made the bores bigger because obviously they were trying to compete now with the Cummins came out with a 6.7.
Yes, exactly.
And the Duramax was a 6.6. So we got it. We're over here with 6.0. We're going to have to step it up.
Yep.
So we're just making the holes bigger. They did change castings and some things. But they are so very similar. And when they did that, they put the high pressure common rail system on, and they didn't think about the rocker assembly because now the rocker assembly never did oil very much.
And this is all making sense now about why the rock. Okay.
You know
why? Oh, I totally know where we're going. So carry on because everybody else needs to know the story, and it's just not just in between me. So yes. So they go from the old Huey that's splashing oil when it's firing to high pressure common rail.
Right. Where's that oil?
Same rocker arm.
Same rocker arm. They drilled a hole at the end of it.
Middle of the hole for it to bleed oil out of?
The tip of it.
The tip of it?
Yeah.
Of the rocker?
Sure. Why not?
Okay.
Yeah, that's kind of what I said.
Okay.
That's it. That's all they did. They drilled a hole under there. There's the same hole that's rolling through the lifter. It didn't get in anywhere. Actually, if you start up a 6.4, this is terrifying. If you start a 6.4 at ambient temperature of, say, 70 degrees, start your clock watch. It'll take you 4 minutes before you get hold of the rocker.
Okay.
That's terrifying. I mean, it really is bad.
Yeah.
That's pretty bad.
So their idea was, okay, we're going to take the rocker. It's got this push rod in it, so we're going to let it just have a hole in.
It already had that hole. They just drilled a hole at the other end.
The other end, thinking it's going to go over.
I don't know.
Anyway,
I don't know. You tell me.
Yeah.
Because so it goes up the push rod like it did on the other one, and it's supposed to trail down the rocker and onto the valve bridge and lubricate. Well, they didn't. They just drilled a hole in that See, that's the only real difference that you're going to see between the two. Rocker ratio is the same. Nothing changed. It's the same stamped rocker. So it did not lubricate.
Right.
Because there was no lubrication there to be had anyways.
Yeah.
Which is one of the reasons why we developed the lubricating, the valve cover that actually lubricates, which is what you see on the table and what's behind me. But while we're talking about the 6.4, they also had issues with piston cracking. Because, again, the name of the game is meeting the emission standards. So combustion bowl is as important in the piston for a diesel engine as the port design is for, say, a carbureted engine. Right. Atomization, keep in mind, for a diesel engine actually occurs
right
in the
there.
cylinder.
Yeah, it's there. It happens there.
Right. Not in the port where everybody else is thinking that, they try to take a lot of the things with a gasoline style head port and try to relate them to the diesel port, and it's if anybody's seen a diesel port on it, they're tiny. They're compared to pretty much any gasoline engine.
Well, it's apples and oranges in a big way. The fuel's very different in terms of the distillation temperature of the fuel, but you still have the same problem. We don't burn liquid fuel. This is that simple fact. It has to vaporize for it to burn. So the atomization process is helping move it from solid liquid to liquid droplet so they can more easily vaporize, and that's the goal of those.
Yeah, and in order to do so, they have basically two different designs, and Cummins had played with this. 2003, 2004 and a half, they changed their combustion bowl design. One's a reentrant piston where the combustion bowl actually, if you were to do a cross-sectional view of it, you'll see that the combustion bowl actually wraps around and there's a lip. And the whole purpose of that is to try to force that heat back to the center of the piston. It also does cause for more areas of heat down towards the pockets because the auto ignition temperature of hydrocarbons is around 750 degrees. So they can burn those off if they can get that bowl a little bit hotter. So that's great. In theory, it works really well, and it can work really well. The problem with it is a lot of times guys in the diesel world definitely like to tune their trucks. I mean, if you've got...
Really?
Yeah.
I didn't know that.
I'm telling you. Who'd have thought it, right? So the issue...
I mean, all that black smoke on those trucks, whenever, is it by accident?
No, it's not because they've got a filter over there, or a bag over their filter, but that is definitely problematic when guys start tuning trucks to the no man's land. What we found about 28 degrees is where you that's the stopping point.
Okay.
Some of the tuners that I know of on the market that we're tuning are seeing 32 degrees injection timing, and it wouldn't matter if it was the LML or it was the 6.4 liter. We start seeing pistons crack, and we talked about that through. It's actually not a crack that occurs. It burns a hole, a tiny microscopic hole, and it splits like a watermelon on July day. That's kind of the way it works. So the 6.4s were plagued with that. The fuel issues of going through regen and being left on the cylinder wall, it's wiping that fuel back down in the crankcase. And, the things that you see from that are a lot of spun main bearings, a lot of problems on the bottom half of that engine. So, there's a lot of things that can be done for that we have done for fixing that engine, be it pistons, total seal. I'll have to put a plug in. But total seal makes, one piece ring on that.
Second ring. Just, it works really good for keeping the fuel
where it's supposed
to be. Out of the crankcase. So you mysteriously get 3 quarts of extra oil.
I just added value, right? They did do away with that. They actually came back later and said, because the other thing that was really funny is this to me is just absolutely hilarious. It's a low maintenance engine, which nothing could be further from the truth. That is the engine that has definitely helped us more than any. I mean, that's our specialty, our bread. And we do so many things to fix it. It's a great truck. Really and truthfully, it's one of my favorites that Ford ever came out with. It's got a great trans in it. It's a good looking truck. It's got good suspension. Drives great. The engine was just definitely this insufficiency. But there's many things that we've done to
fix that.
To fix it.
So talk about that. Let's talk about what I see these cool looking pistons over here. So tell us what you did with the pistons to fix the problems.
So the pistons are actually a redesign. They're not the 224-3666 part number that Molly came out with originally.
Okay.
It's an international version of that pistons that we start with.
Okay.
So it's a little bit thicker in the crown of the piston. We machine the bowls out to our specifications, so we don't have some of the cracking issues that we had before. And then they're polythene coated. You'll see valve reliefs in these. We work with Billy Gobble over there to develop a camshaft that helps lower AGTs and increases spool up. So it promotes better spooling for the turbos, and doing so. It gets a little bit better mileage out of the vehicle and a lot better drivability.
So those are actually valve reliefs.
Those are valve reliefs.
Okay, cool.
Correct. So on top of that, obviously you see the valve cover that's on the table there that actually has an oil rail system that goes through it. And what we basically did was we took the idea of the 7.3 head. Now the 7.3 head, the way that it worked on a 7.3 would be you put the injector in here and there's this long rail.
Okay.
And it filled this cavity full of oil, and then the oil would feed the injector.
Right.
The 6.7, when Ford came out with the 6.7, they realized everything we had problems with, let's just take everything that we know and try to put it into one engine and fix all these problems.
Okay.
So what they did, guess what? They came out with an oiler for their rocker arms, which wasn't really necessary for the 6.4, or excuse me, for the 6.7. But I think they got burned so bad.
Oh, yeah, they weren't going to.
Yeah.
Hey, listen, hey, proper lubrication, right oil, right place, right time, right amount. They're like, we got burned on these two before.
Yep.
We're not going to be burned again. We're going to make sure we get plenty of it there when it needs to be there. Not going to get burned on that one.
Right, and they did. So they wound up putting a tube rail system down. And when we originally started making this design, we did that. Then we found the thing that, and I say this all the time, if you've seen any other interviews or any podcasts that I've done, I love Chrysler's little motto, fashion by function. And, you know, it's a pretty valve cover. Everybody likes billet. Everybody likes aluminum. Everybody likes something that's machined. But I like something that works. So the original tube design worked, and it worked good. But we figured, you know, there was a better way to manufacture it. So what we actually did was we took that same idea from the 7.3 with the head with the rail on it. And then we took the 6.7 design with the old rail. We meshed them together. We came up with a design. And then we made it for the 6.4. So what this cavity does, the things that we've seen with it, we've seen temperatures drop because it does act like an oil cooler.
Oh yeah, it's a big giant heat sink, right? It's perfect. Exactly. You run oil there and it's going to radiate heat out because it's the heat transfer properties of aluminum are fantastic. So it's cooling the oil, which is a fantastic thing.
Yeah, it adds, there's so many things that are functional to that. So with the orifices that we've got in there, it sprays right down on top of the rockers. So, and the thing that we've noticed about this is that it actually lowers the, at idle, the sound decibels by 10 points. So it's pretty crazy.
10 decibels.
10 decibels. So that goes to show you, you know, if you've, and you know better than anybody, but being around a Spintron, people just do not realize how much valve train noise.
Oh, it's
incredible. Yeah, I mean, if you didn't.
Well, you know, my buddy Ben Strader, right? Yeah. All the time showing these videos. They're like, how much power to make? It's like, it's a Spintron. That's not firing. I know, I heard it firing. It's like, that's just the valve train making the noise. Literally nothing else.
It's pretty crazy. The first time I ever walked down Comp and they were running one, I was like, this, you know, I couldn't believe it. It was just, it's unfathomable how much noise a valve train possibly can make.
So this spraying on the valve train, 10 decibels. That's pretty cool.
It is so much so that it's quieter than my new 6.7 Powerstroke.
Okay, I'll say this. My wife wants you to sell these to everyone in our neighborhood that has the big trucks.
We would be more than happy.
Keep them quiet, you know?
That's right. So it does. It makes a huge difference on that. And so that fixes the problem as well for them there. With the 6.7 Powerstroke, it was a whole completely different design. And the reason why I say that is heretofore, International had made the Powerstroke engine.
Right.
International is also known for
tractors.
There you go. And so it's an industrial application or commercial application. Well, Ford didn't think about that at all. They have one purpose for that engine and one purpose only, and that's to go into their Super Duty lineup.
Yep.
So they started from scratch, but they kept their notes, and it's pretty interesting. The motto, the main theme of the 6.7 Powerstroke is weight reduction.
Okay.
In every form and facet of that engine, from the block, that's a compacted graphite iron block,
Okay.
to the turbocharger, that is a dual plane turbocharger. It's
Nice.
a single sequential turbocharger SSD. Well, it was. That we can get into that if you want, but that turned out not to work out too well for them. So
We'll save that for another day.
yeah, but the 6.7, they really thought about weight reduction through the connecting rods, which turned out to bite them.
Okay.
And they wound up changing that in 2017.
All right.
And beefing up the rods. I mean, it's a diesel. At the end of the day, come on, man. Save money somewhere else.
You still got compression.
Right. Just tell the guy to get out if you're trying to,
Right, yeah.
But save the weight where it needs to be.
So what was the static compression on those engines before they,
The static,
with the light rod, I should say?
The compression ratio of a 6.7 was about 16.8 to 1.
So it's still really, still really high.
It was definitely high. But they really had issues with, if that engine had ever been hydrolocked for any reason whatsoever.
Oh, it was done.
Oh, it's done.
Yeah.
Bad.
Yeah, I didn't have the chance. Right. Okay.
So that was a major flaw that they had.
So upgrade the rods as they went forward. See, I'm thinking back to the rocker arm thing. The timing of that 08, 09, 10 era there, that's right when the CK4 diesel oil came out.
Exactly.
And that same era, and Ford was the first one to break ranks with API and say, no, you cannot use the new oil in it, because they were having rocker arm problems. Because back to right oil, right place, right time, right amount. Well, what's the right oil? It's the right viscosity and additives for the application. And like you said, they were already marginal on the edge. That little bit of change in additive package pushed them over the edge, and they were like, no, we're not doing it.
Right.
You have to run the old spec oil in those engines, no way around it. And then of course that did get itself worked out over time, but that was interesting, that those little...
They were right. Yeah, it definitely has wreaked havoc. Ford, which is interesting, because Ford is definitely the first on the scene when it comes to diesel. Now, it doesn't matter, I've said this before, it doesn't matter if you're a Cummins guy or a Duramax guy or a Powerstroke guy. Ford's always the first on the scene with anything. And you can't argue that point, because Ford was the first to use a compacted graphite iron block. Ford was also the first to try ever for a dual sequential turbocharger system on the 6.4.
Okay.
They're the only ones to use the Huey injection system. Ford was the first to ever use a steel piston.
Okay. See, that's cool right there.
Yeah, and they cranked their rail pressures up to, or ejection pressures up to 36,000 PSI.
36,000 PSI. That's still just mind-boggling.
It is. It is pretty incredible. So it doesn't matter. They were also the first, when I'm saying first, I'm saying for automotive applications.
Right. Yeah.
Right. But the reverse flow engine. Now the intakes are, instead of being on the inside of the engine, and now it's just reverse. So now your intakes are on there. The valve cover actually acts as the intake on the 6.7. It's a teardrop flow that you've got now. That had never been done before in an automotive application for a diesel engine, for diesel pickups. So they were the first on the scene for that as well. So there's so many things that Ford was just the first on the scene to do. They were the first ones to use a variable geometry turbocharger in 03 with the 6.0.
Okay.
Later, unfortunately, it's almost as though, and I'm not picking on the other guys, but it's almost as though GM sits back and Cummins sits back and go, let's see how it works out for them. Because they really did.
Yeah.
03 was the first year for the VGT, for the 6-liter, and then following suit, General Motors came out, or Duramax came out in 04 and a half. The LOY came out with it.
Got it.
And then Cummins didn't come out with it until 07 and a half. So you can't argue the point that they are the first on the scene with everything that they do in the diesel world.
Well, it sounds like it also keeps your life interesting too, right? They're always coming up with something new and different, so there's going to be new fun challenges and things to fix and things to learn. So it's never a dull day when it comes to the Fords, huh?
It's true. But the 6.7 was it's an interesting engine, keeping with the lightening of the rotational assembly. They lightened up the from 11 to 15 harmonic balancers. The earlier year model flex plates were a little bit lighter. They were just trying to get everything to be as responsive as it possibly could with less rotational mass.
Okay.
So that was it tended to end poorly in some areas.
Okay.
But they wound up putting a larger harmonic balancer on it. They found out that first order imbalances were a thing, and that definitely needed to have some type of absorption for the combustion events that were taking place, because they had crankshafts that were failing.
Okay. Yeah.
So that was a problem. So there's a lot of things though that the 6.7 fixed. But with everything, as you well know, it seems like when you fix one thing in designing, something else changes.
Yeah. You just keep moving that weak link to the next thing. You uncover what the next thing that's going to not be able to hold up to what you're asking it to do. But you've kind of painted a picture. Someone could listen to this and say, man, they sound like they're terrible motors or they're hot garbage. But in reality, I think what you're really saying is this is an excellent platform to hot rod.
Oh yeah, absolutely.
Because there's they had these inherent design problems,
right.
Which if you get in with anybody that does one engine platform or a bunch of it, they're going to be able to tell you every dark, dirty secret about it and make you think you should never come walking near one because it's going to blow up and kill you like a grenade.
Yeah.
But the reality is they all had their strengths and weaknesses. Sounds like, again, this platform has got some real potential for some pretty cool stuff on the aftermarket side for hot rodding it up, because of they did push the potential.
Yeah. I mean, if you talk to me long enough on Cummins or Duramax, I mean, you'll walk everywhere you go after I mean, that's just...
You're making me buy my Mercedes more and more, right? It's 48,000 miles, 40 years old, still runs.
Who cares what gas is? I've got a bicycle. But, that is definitely, it is a great platform. Again, they upgraded the cross bolt mains. So there was a lot of things that they did, and a lot of things that the new 2020 came out with the steel piston design, bigger connecting rods, automatically right out of the gate. Those things are, the horsepower ratings, I believe, are a little over 500 horsepower, well over 1,000 foot-pound of torque.
Man, that's just,
it's pretty incredible.
That is.
Yeah. But
that's a factory engine, 1,000 foot-pounds. That's just pound-feet, whatever. I don't know. Criticize against mine, but I get it. But
you have to go, so many people go, well, they don't make them like they used to. And the truth is you're absolutely right. They don't make them like they used to. The 7.3, will it live forever? Sure. It never made enough power to hurt itself. Okay. Sorry. But it's true.
This is like my Mercedes. It makes 67 horsepower.
That's true.
It'll never die. Because, like I said, it can't make enough power to hurt itself.
I mean, right now, guys are swelling up and that own 94 to 97s going, I've got Ford's rod. You're not ever, it's not going to make enough. But it's the duty and the demand of the new diesel engine is so great that right out of the gate you're asking that much power for this thing, and you're asking for it to be compliant. So you really put it's
a big ask on both sides.
It really is
to make that kind of power, but also do it and meet emission standards as well, which are incredibly hard compared to what it was 10 years ago.
Yeah.
In light years compared to what it was 20 years ago. Because 20 years ago, really, there wasn't any standards.
No, there really wasn't.
And now it's treated like a gasoline engine, essentially.
Exactly. That's exactly right. So there's been a lot of changes, especially with the steel pistons, and there's things and nuances, and I encourage anybody to give us a call, because there are things that we know about these engines that, I can tell you right now, guys are buying 2020. This is, you being the gearhead you are, can appreciate this, but guys are buying replacement engines for their 2012. Ford is only making one block, all right, for that. But the way they're machining that block is for steel piston. But this guy's using it for a cast aluminum piston.
Ooh, I see problems already.
Yes. Yeah, that's a big problem.
Yep.
Like thermal expansion rates are quite different.
Big difference.
Yeah. So, we see a lot of problems with that kind of thing. And, there's a lot of information that we're able to tell the customer and save you thousands and thousands of dollars, save your truck from being down and you not being able to get to work.
Right. That's a big deal.
And
I'm sure a lot of your customers, that truck isn't a race car.
Right. You like to use it as one.
Right. But it is their daily driver.
Yeah.
Like for real, daily driver.
That's right. So, and we talk about the big demands that are on it. Not only are you asking it for 1,000-pound feet, you're not only asking it for emissions, but you're also asking it to be able to race on the weekend and drive on the weekday and pull a trailer with your horses to, your daughter's barrel racing competition.
Exactly.
That's a lot. I want everything in one,
Right.
and we know that from, machining equipment or whatever. Typically when you get something that does everything, it never does anything really, really good.
Right.
But not in the case of the diesel engine. It's more efficient, always will be. The pros of a diesel engine are always going to be better because the British thermal units in a 1 gallon of diesel fuel is about 138,000 BTUs to a gasoline that's 120-ish, 125, 126. So you're always going to have a better efficiency with that. There is so much to be had from that you can't ignore it. So we're a major proponent of diesel for those reasons. And for hot rodding and for daily driving, there's a lot of good platforms out there. And people ask me all the time, if you're going to buy a new diesel truck right now, which one would you buy? And the truth is there are problems with every single one like there are on every vehicle.
Right.
But again, and I'm the worst person to ask because I do know all the insufficiencies or some of the inherent problems with them. But there really isn't a bad one on
Right. They're all really actually pretty daggum good.
Yeah, they really are. So there's some things to think about with that.
That's cool. Do you see some people going back and trying to buy some of the older pre-emissions vehicles? Are they really in demand because of that?
Well, I don't know if it's in demand because of the emission deal or not, but they definitely. The crazy thing is that the 7.3 market is just. Or if it doesn't matter if it's a 7.3 market or if it's 12 valve guys, the Cummins, or it's the Duramax, LB7, LLY, LBZ guys. These trucks are bringing insane amounts of money. And it was even that way before the pandemic when now.
Oh yeah, right now everything's ridiculous.
Yeah. Actually, I went to go at the local dealer to buy a 4-wheeler this weekend, and of course there was nothing in there to buy. And he said, just put $100 down and wait your turn.
For a 4-wheeler.
For a 4-wheeler. But even with that, the prices of those diesel trucks have been just through the roof because there's a following there. There's a loyalty there. That square body is a classic already.
Yeah,
And it doesn't matter. Guys love their trucks. And it'll always be that way, I think.
Hey, listen, anybody that's ever pulled a trailer up the hill and passed another dude, passed a car, it's how it is, right?
We don't like to downshift. These diesel guys, that's just a bad thing.
No, I'm gonna drag your ass up the hill if I do.
So, that's the great thing about a diesel. You just set it on cruise and you don't ever see it kick out of the 6th gear. It's just gonna, it's got the torque that you need for pulling, and there's no substitute for that.
No, there isn't. There isn't. Anyone that's ever pulled a trailer with a gas engine and a diesel, you don't have to know just the once. That's all it takes is the once, and and there's no going back. You gotta have it.
That's exactly right.
Well, cool, man. Thanks for the time. I appreciate you, speaking to the audience and everybody know what you're doing. So if they want to reach and touch out with you, what's the best way for them to talk to you?
You can email us. You can go on our website at choateperformance.com and reach our email through that, 901-553-9847. We have a Facebook page, Choate Engineering Performance. You can look us up there or find us on Instagram at Choate Performance. Those are all great ways to get in touch with us.
Awesome. Sounds good. All right, Mr. Costello. Back to you.
What a day, what a day, what a day. Yeah, my brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.